experts in the healthcare and medical IoT ecosystem. We talk about some of the challenges as to why these security and privacy problems occur. And then we'll talk about how do we mitigate these problems. We understand these are challenges. We understand there are breaches. What can we do about it? And this is going to be especially attractive if there are any engineering teams or executives from small and medium-sized businesses, but also large corporates. Because when it comes to digital healthcare and problems associated with medical devices in today's market, these are new and interesting challenges, right? So this is affecting not just the startups, but also these established corporations that have been doing healthcare for decades now. No presentation about healthcare cybersecurity is complete without talking about regulatory requirements. So we'll spend a few minutes over there. And finally, we'll conclude talking about what are the next steps. If you're a company that cares about cybersecurity, which I'm pretty sure all of you do, you might be doing some of the activities that I talk about already. But we will provide you with inputs. If you're a company that needs more assistance or guidance, we'll start, we talk about how you can start taking those baby steps towards establishing maturity levels for your organization and how do you achieve them over a period of time. Attacks on healthcare and medical devices have been happening for a while now. For nearly a decade, we are seeing a lot of these attacks happening on IoT ecosystem in the healthcare side. Some of these have been in the form of presentations at security conferences, most notably at Black Hat. We have seen presentations on attacks on things like pacemakers, insulin pumps, and so on. But also more serious as some of the headlines that we've seen in the recent past, including last year, where a German hospital was hacked. And this indirectly led to the patient actually dying because of this kind of a cyber attack. Ransomware has been one of the biggest problems plaguing the medical community. In fact, I'll show some statistics in the coming slides. But we are looking at ransomware affecting a large population when it comes to a large sector of these medical and healthcare service providers, and that being more than 50% of the cyber attacks that these companies, these institutions face. And not surprisingly, if you look at some of the statistics, as per a study conducted recently by the Ponemon Institute, and a study research that was done in conjunction with IBM, it is seen that the average cost of a data breach in 2020 was $3.86 million. But it's no surprise that healthcare had the highest cost, nearly double of what the average was, at $7.13 million. And this kind of a statistic has unfortunately been plaguing the healthcare industry for quite some time. Healthcare has been at the top. It's been the highest in terms of the breach cost for 10 years in a row. So this is serious. So this is something that every healthcare medical device manufacturer, healthcare company needs to take it very seriously. Because as we start increasing in terms of digitalization and use of some of the modern technologies in healthcare, these security problems are just going to grow. And some more statistics, again, troubling in some cases, is the root cause, right? So security attacks can often be through malicious actors. It can be through glitches, sometimes unintentional, things going down because of an upgrade or a regression and so on, or human errors, again, intentional or unintentional. What we have seen in terms of, again, statistics and the healthcare industry and medical device attacks has been that 50% of them have been malicious. This means that this is a very targeted sector, right? So this means that whether you're a big company or a small one, you've got to pay attention because they are coming for you. Also, in terms of the average time to identify a data breach, this is upwards of half a year, nearly 236 days in terms of average number of days to identify a data breach, and 93 days to contain a data breach. This is also particularly troubling and also justifiable, because when you're talking about containing a data breach, it means identifying the hack, doing the root cause analysis, doing the recovery, and performing all of these, not only balancing your PR, your messaging publicly and so on, but also making sure that your services are up, your data is up, so that your customers, your partners, your vendors are not affected by this data breach. doing the recovery and so on. So no wonder it's 93 days on an average to contain a single data breach. So why is it so bad when it comes to cyber attacks against healthcare, right? So why do we see such numbers where we're talking about double the average when it comes to a cost of a data breach? As we discussed, healthcare has been at the forefront of the overall cost when it comes to handling a data breach because of rapid digitalization, right? So we are seeing newer and newer technologies being adopted over the past 10 to 15 years. What's also challenging is that in a healthcare environment, it's a very collaborative space. So you have the hospitals, you have the healthcare service providers, you have the patients, you have the partners, and you have all of these disparate entities working together, which means unlike a very traditional, let's say a software or an IT organization, it becomes very difficult to enforce some of the network related checks and security perimeters that you normally associate with. So it is by design required to have all these services, to have all this data being available across different boundaries from a network point of view. We spoke about digitalization, use of some of the modern technologies such as IoT, cloud, the newer wireless protocols, and integration with different kinds of software services. So these are throwing up new challenges for healthcare. And this is also an attractive target for malicious actors, because when you're talking about healthcare, you're not only talking about PII, which is personally identifiable information. You're also talking about personal health information, financial data, medical IP, and so on. This is so much so to the extent that the value of patient records in the dark web is said to be nearly 10 times the value of stolen credit cards. And you think protecting your credit card information is much more critical, right? But the so-called the malicious actors in this case who seek to gain money out of these hacks value things like patient records much more than credit card data. Ransomware and extortion has been a big pain for the healthcare sector. They account for more than 50% of the data breaches and incidents. I would say data breaches is kind of very focused in terms of definition. But in terms of security incidents, you can count ransomware being one of the biggest problems. And also when you're doing medical devices, you don't really make it for one country. And this is where the regulatory challenges come in, because you can have a very different set of rules and guidances, let's say in one part of the world, which is very different from, let's say, what's happening in Asia as compared to, let's say, Americas or Europe. So being able to develop these devices, being able to develop these kind of hardware software platforms, making them available and comply with the regulatory requirements around the world can be a big challenge, not only in terms of development, but also in terms of security. There are also a host of technical challenges in the space. Securing any kind of digital platform is hard. And this is not just for healthcare, right? So security by definition can be pretty tricky because the attackers have to get it right once, but as defenders, we have to get it right every single time. And this plagues not only IoT markets, but also like web applications, mobile, and so on. But when we dive down into IoT or Internet of Things, securing Internet of Things is particularly messy because Internet of Things range everything from a pacemaker inside your body to a traffic light outside my house. So this makes it particularly challenging to draw security best practices and guidances across all these kinds of IoT platforms. So again, this is not just for healthcare, but across IoT platforms and IoT categories, you find that security is one of the most challenging activities. The other concern with healthcare is that you have a lot of legacy systems, both in terms of hardware and software. And you have this, if it's not broke, don't fix it kind of an attitude. So you have these existing systems which are working perfectly fine. Now you got to IoTize them, which means that you need to add more layers of code, write some wrappers, and have them working with the cloud. And this can be particularly troubling for security people, because now you have to understand these legacy systems, do the threat modeling, not only for the existing platforms, but also for the interoperability and the ecosystem when you bring these different not only different platforms from a technical point of view, but from a generation point of view, that you have to make sure that you do the security analysis in the right way, which is exactly why some of the traditional security approaches do not work. Because from a security point of view, you have these security development lifecycle, the SDLC processes, threat modeling approaches, and so on that have been there for a few decades. But when it comes to IoT, and particularly healthcare under IoT, many of these best practices may not work anymore, because now you have these very unique kind of systems, unique kind of architectures, unique kind of communication channels, and also some of these regulatory requirements, the kind of data that needs to be protected in a different way. So all of these challenges come together, and that's why we are seeing that healthcare is paying a lot of attention to security. It needs to evolve how it does security. And likewise, some of the regulatory challenges, regulatory requirements are also evolving as we speak, in terms of how you make sure that these platforms are adequately secure. All right. So we spoke about the attacks. We spoke about how some of these platforms can be exploited. We spoke about some of the challenges. So let's talk about how we can address them. What can we do about all these challenges? So at Deep Armor, we believe that you need to have a holistic approach. You need to have a comprehensive approach whenever you're securing any kind of product or a platform, right? So it's not enough to just run some tools, click some buttons, get some reports, and take care of security in that angle. Broadly speaking, when we look at security development lifecycle, or SDLC as it's commonly referred to, sometimes SSDLC, software security development lifecycle, you have two parts to it. One is the process angle to it, in terms of how you define the security processes, right? So who are the stakeholders? What is your process for your particular products and platforms? What are the inputs and outputs at each stage of the security development lifecycle? How do you prepare for dealing with security incidents? How do you respond to them? So on the one hand, you have all these security processes. On the other hand, you have all the security assessment activities, which are the technical evaluations. So put together, one side is the planning and the strategy, the other side is more tactical and the execution angle. This can help in defining the right kind of processes, as well as the maturity levels and the activities that you need to execute in order to meet those security standards. When I say security standards, a lot of it is, again, derived by what the regulatory authorities say. Depending on where you are, where you're selling your products, what are the target markets, you can have different regulatory requirements. So we'll come to that as well in the following slides. So the process takes a lot of time, and also one of the most kind of, I would say the effort that goes into creating some of these processes is often underappreciated in the community. But having a good security development lifecycle often makes a huge difference in terms of how you lay the foundation for the security of your platforms. There are a lot of SDLC frameworks out there. So if you just Google for waterfall-based, agile-based hardware, software, firmware, there are a lot of practices, there are a lot of best practices, as well as playbooks for doing SDLC. But in our own experience, we've seen that it's extremely important that you customize some of these frameworks for your products and platforms, because these are rarely one size fits all. So when you're customizing, you're defining who are the stakeholders. And if there are any startups and small and medium-sized enterprises in the audience, this also means that getting the buy-in from your management, you define the security and privacy activities. We'll come to that in the next slide. And you also do a right kind of mix in terms of the manual activities as well as tool-based activities. And then you do everything that you can to get security right proactively. But it's usually a question of when and not if that you get hacked. Right? So when there's a data breach, when there is a security incident. So it's also very prudent to be prepared on how to respond to a security incident so that you're not caught unawares when such an incident happens. Because oftentimes when an incident happens, it's usually a question of days. If you're lucky, it's weeks. It's usually a question of days when you need to make a decision on how to move forward. And when it is you, I mean that it's everyone from your executives to the architects, to the developers, to the testing team, as well as the deployment team, so that you know how to mitigate this kind of an incident as quickly as possible, as responsibly as possible, not only protecting your users, but also protecting the brand image, your investors, your partners, and so on. So it's from a financial perspective, from a business perspective, as well as from a user's perspective, that the incident response process needs to be addressed and designed. In terms of how do you define SDLC? So I said that there are many best practices, many templates and guidances. There are no one-size-fits-all, but at the heart of it, most of the SDLC practices have the set of activities that tie in to the product development lifecycle. So which means that when your product is POR, when there's a plan of record and your product is approved, that's when your security activities start, right, at that time. So if you notice the blue boxes there, you also notice that there are privacy markers, not just security markers. So this is because when it comes to a lot of IoT systems, and particularly in healthcare, privacy plays as big a deal as the security of the product and security of the data. So there is the intertwining of security and privacy activities that start with the program POR, all the way through design, implementation, launch, post-launch, development, deployment, and maintenance, right? So in that sense, you have these S1 to S5, as we call it, that happens through the product development lifecycle pre-launch. And once you are at the launch stage, there's also this Delta security development lifecycle, or Delta SDLC, which ensures that you are continuously being up to date and providing security updates as required. I'm not going to dwell over this too long, but I think the audience appreciates that shift left, or inculcating security, incorporating security early on in the product development life cycle makes a huge difference. The cost is exponentially higher to address a security vulnerability, not just from a technical point of view, but also from a response point of view, where the cost goes up exponentially the later it is, especially when it is post-production, when it is already in the market, where an incident needs to be handled not only by the engineering teams, but also by the executives, by the PR and others. All right, so let's talk about healthcare IoT ecosystem. So how do you incorporate SDLC? What are the different activities that you need to execute for a typical healthcare product? So a typical healthcare product, again, can be pretty tricky to define in terms of architecture, but broadly speaking, you see these building blocks, right? On the left-hand side, you see this hardware, kind of the actual medical device, the main, the block which holds the IP, which performs all the activities, the healthcare actions and so on. This could be connected to peripherals, it could be connected to sensors, etc. In many medical devices, you also have a mobile component, oftentimes used as the local cloud, but also used for configuring, for doing provisioning, and so on. And cloud almost is an essential component of most digital healthcare platforms today. By cloud, I don't necessarily mean AWS. It could be any of the public cloud service providers. It could be a hybrid cloud. It could be your own private cloud where you connect to a data center. You have these services that you maintain, your server infrastructure, server farms, etc. So the cloud has the bulk of the intelligence. You have all the data, the analytics, you have the dashboards, the electronic medical records being stored. And in many cases, the cloud is the medical device, right? So there is something called SAMD, software as a medical device, where you can have a bunch of algorithms that ingest data that is collected by other third-party software and hardware. And then you perform the analysis and produce results, medical results, right? So in that case, the software is a medical device. And then you have this connectivity tissue of different kinds of wireless protocols. So it could be near-range wireless protocols like Bluetooth, BLE, NFC, ANT+, Wi-Fi, and so on. It could be long-range like HTTP, HTTPS, NB-IoT, Cat-M1, and so on. So you have all these, I forgot to mention, so you also have third-party software and services. So it could be open source software. It could be other paid proprietary software and services that you use for performing certain activities that you don't do yourself. You have these business negotiations, you have these agreements, and oftentimes it could be in the form of making API calls, incorporating their libraries in your code, and performing certain activities that yield the results that your product does. So you have these 4 or 5 building blocks that make up your ecosystem, that make up your architecture. Naturally, the next question is, what should you secure? Fortunately or unfortunately, the answer is everything, right? So if you were to draw the attack scenarios for each of these, you see that every one of these building blocks has a threat surface that it exposes. From a hardware point of view, you have these hardware devices that interact with other peripherals, with other sensors, with the cloud, with mobile applications, and so on. And therefore, you need to make sure that that hardware and the code running on the hardware, often referred to as the firmware or even the operating system that that platform is running, needs to be adequately secured. Which means some of the paradigms that come into picture are what you see in the white bullets, the small print there. Things like secure boot, secure firmware over-the-air updates, or even wired updates, crypto management, key management, at-rest encryption, which is required by many of the regulatory compliance requirements, device identification, device attestation, protocol attacks, provisioning, decommissioning, secure decommissioning, and so on. They are some of the hardware-related and firmware-related security paradigms. Similarly, on the mobile side, you have the application security, you have secure crypto, secure provisioning, and on the cloud, you have these host of problems that from a security point of view, you need to address, not only from a design perspective, but also implementation and testing perspective. You have the user management, role-based access control, data classification, network security, again, crypto key management in the cloud, API security, secure configuration. And then from a third-party and service software services point of view, you have this mix of business as well as data and network security requirements, where you want to make sure that they are not ingesting data from your services that they're not authorized to. They're providing you with secure values. They're not trying to subvert your system inadvertently or intentionally. So all of these white bullet points that you see on this slide, they are the starting points for how you start doing security for your healthcare and IoT and digital IoT platforms in the medical space. Right. So I'm going to talk about regulatory requirements for the next few slides. There are a bunch of them. When it comes to healthcare regulatory, it all depends on what your target market is, where you as a company are present, or where you are marketing your devices, where you're marketing your products, your healthcare products. Predominantly, we'll talk about US and EU and India for this particular presentation, but this can be a presentation by itself. So when it comes to the US market, the Food and Drug Administration in the United States defines 3 classes of medical devices, classes 1, 2, and 3, in the increasing order of the risk that they pose to the patient safety. Class 2 and Class 3 need to go through a process called the FDA 510K, pre-market notification or pre-market approval, 3 being the most rigorous, and you need to go through a whole bunch of checks and you need to meet those requirements. And one of the recent additions over the past few years is that cybersecurity is playing a major role for the pre-market clearance as part of the 510K process. So predominantly for Class 2 and Class 3, but also certain Class 1 devices, where there is a risk to patient safety through cybersecurity methods, it is required for these products, these medical devices, to go through a process of risk assessment, security evaluation, and also preparedness in terms of incident response and so on. Similarly, in the European market, you have the medical device regulation or the in vitro device regulation, the MDR, IVDR, and the CE mark associated with that. So in order to get the CE mark for a medical device, you need to pass the MDR and the IVDR requirements. And under the MDR and the IVDR, you have the Medical Device Coordination Group, the MDCG 2019-16 guidance, which talks about the cybersecurity requirements for each of these medical devices. So under these, again, you have the risk assessment requirements, the incident management, security development lifecycle, threat modeling, pen testing, security code reviews, etc. The MDR was supposed to go live in May of 2020, but because of COVID, it got pushed to May of 2021. And some of you may have more information than I do in this case, but from what we understand, MVDR is fully applicable as of now. And in vitro device regulations is going live as of May 2022. All right. So what does all of this mean when we say that you have these regulatory requirements from the FDA, from the MDR, IVDR? So if we read these requirements, especially as engineering teams, these can be pretty difficult to digest, right? So you need to understand that these are government documents. Some of them have a lot of legal speak. So one of the challenging tasks is understanding what these documents are saying and translating that to engineering speak, which means if I am a company that is developing a product, a medical device, or a software as a medical device, it could be hardware or software, what does it mean to me if I need to go and sell my product in Europe or in America, for example? So one of the challenges is digesting these documents, converting it into engineering speak. But this is something that is being done actively by many big companies. At Deep Armor, we do this as well. The screenshot that you see here is essentially a mapping of the 23 security recommendations that the FDA provides as part of its 510(k) pre-market readiness guidance, and then creating a threat model out of it, which means that on the left-hand side, if you see the first column, the 1AI, 1AII, and so on. So we have translated these requirements from the document into a threat model of sorts. So where we define the security requirements, the threats for each of those security requirements, and the vulnerability vectors, which means the security testing vectors that map out for each of those threats. So this becomes actionable now. This is no longer a document that speaks about the legal requirements, that speaks about the readiness, that speaks about the justification and so on. But this is something that can be used by an engineering team, by a security team. And these are some of the specialized tools and approaches that we are developing so that this becomes useful for the actual corporations and startups for implementing some of these requirements. Similarly, we have dashboards where we talk about the coverage of what for example, FDA is saying similarly for the CE mark, whether some of these requirements are covered through design, some of these are covered through risk management, some of these are covered through security validation approaches. So where we act on the product, where we provide our services in terms of doing threat modeling, the pen testing, the architecture reviews, and then make sure that there is sufficient coverage, partial coverage, or inadequate coverage kind of an information that can be used for taking this data back to the authorities, the regulatory authorities, and getting the product certified. Specifically in India, this is an interesting space in India. So the Ministry of Health and Family Welfare, the MOHFW, has a few initiatives in the healthcare and protection of sensitive information. One is an effort called DISHA, Digital Information Security in Healthcare Act. This is a draft law that was proposed in 2018. The primary purpose of DISHA was specifically to define data protection and data security guidances for healthcare specifically. So it was all about protection of digital health data. In 2019, more famously known as the Shri Krishna Commission, proposed the Personal Data Protection Bill, the PDP, as it's called. And then the one that's actually in effect and enforceable is the Sensitive Data Protection Rules of 2011 under the Information Act, the IT Act of 2000. So in that we have the Section 43A, which talks about maintenance of reasonable security practices and procedures. And Section 72A talks about penalties for intentional personal data breach. But if you notice, it increasingly becomes broader and more overarching. The IT Act is definitely overarching. This has nothing to do specifically with healthcare, but it is applicable also to healthcare. Similarly, the PDP bill was not meant only for healthcare, but it was also, it gives coverage for sensitive information in the healthcare context. DISHA was actually drafted, or the initiative was started specifically for healthcare. Unfortunately, the DISHA and PDP are still not they have not been passed by the parliament. So there are draft laws at this time. From what I understand, Disha has not made a lot of progress since then. The PDP has been reviewed, and there has been a lot of feedback that has been provided. So the PDP is still active at this time. And for companies that are manufacturing medical devices or selling their medical devices in India, this could be a good reference for making sure that you take care of all the security requirements as well as the privacy requirements. This is the yardstick for, in general, speaking about data privacy and security standards. So if this passes at some point in the future, then this will govern the processing of personal data, not only by the governments, but also all the private companies. No presentation about healthcare security is complete without mentioning HIPAA. HIPAA is kind of a gold standard. Again, this is very US specific. It's a US federal law, so it is enforceable. And it is also up to the medical device manufacturers and the healthcare community to say that they are compliant with it. HIPAA has a lot of sections under it, talks about technical protections. How do you ensure that the data is encrypted at rest? How do you make sure that the access is restricted on a need-to-know basis? What are the administrative protections, privacy activities, breach notifications, and so on. So again, this being a gold standard, this is a good reference point for companies to make sure that they're compliant from a security as well as privacy point of view. There are a bunch of certifications. I've just mentioned HITRUST here for convenience, but there are a lot of certifications by for-profit, not-for-profit organizations. But what these provide is that, specifically talking about HITRUST, it provides a common security framework, as they call it as CSF, where they let you be compliant for a range of other standards, including HIPAA. So you can use the HITRUST services for being compliant with HIPAA, for being compliant with NIST, and a host of other standards in the medical space. So the difference is that HIPAA is a US federal law, whereas HITRUST is a certification, so you can actually pay for getting certified under HITRUST. Correspondingly, in the EU, you have the GDPR. I'm pretty sure this audience is familiar with this. Again, GDPR is very overarching. This is not only for healthcare, but pretty much all kinds of personally identifiable information, personal information, and any kind of sensitive data. And in the EU, you have while you have the GDPR that is applicable to all the EU member states, you also have the country-specific guidances, so which you need to comply with in addition to complying with the overarching guidances. And within that, there are healthcare-specific guidances, right? So if you're a healthcare manufacturer or a medical device manufacturer, there are these guidances that you need to be aware of, depending on, one, whether you're going to the market in the EU, and within the EU, which specific countries that you're going to be selling, or where you will be present. And from a healthcare point of view, there are requirements like, do you have a data protection officer? You have a representative in the EU, especially if you don't have a physical presence there, if you don't have an office there, and make sure that you have a plan for data breaches and so on. Fines under GDPR can be extremely high. Under certain conditions, it could be 4% of your annual global revenue, or $20 million, 20 million euros, whichever is higher. So that can be pretty damaging, especially if you're a small or a mid-sized company and not aware of some of these requirements in the European Union. Right. So this is a topic that we can talk a lot. Specifically, there are some slides which require a lot of time. I would pick this one as my favorite. There are a whole bunch of topics here. When we're talking about securing medical devices or any kind of IoT ecosystem, ensuring that you're taking care of some of these security paradigms, right, from hardware, firmware, wireless protocols, cloud, applications. So this can be particularly challenging when you're talking from an engineering perspective. So I tried to cover a whole bunch of topics here, but as the next steps, I would say that if you're a company that is facing certain challenges, or you want to know more about how do you secure your medical devices, I would say that as a first step, start planning for an SDLC framework, right? A security development lifecycle process that is customized for your products, for your platforms, for the technologies that you use, for the services that you use. And especially if you're a startup or an SME, make sure that you get the buy-in from your executives, because without sponsorship from someone senior up, this can be really tricky. And both from an approvals point of view, from a budget point of view, from a prioritization point of view, because oftentimes security is seen as something that does not give any return on investment. But then when there is a data breach, that can come back and bite really hard. Once you define an SDLC framework, make sure that you have incorporated all the technical and regulatory activities from a planning perspective, as well as from an execution perspective. So once you plan, it is prudent to define certain maturity levels where you say that this is my goal for the next 6 months, this is my goal for the next 18 months, and so on. And then take appropriate actions to meet those maturity levels. One of the fundamental mistakes that we have seen a lot of companies do is that they do not keep track of all the security responsibilities or the liabilities that they have. We commonly call it as the cybersecurity bill of materials. It's a term used by the FDA as well, where you're not only keeping track of all the hardware, the software, but you're also keeping track of what the responsibility is from a security perspective for each of those building blocks for your medical device. And from a technical activities, it's imperative to include the whole gamut of S1 to S5 that I presented a few minutes back. So where you do the security architecture reviews, design reviews, implementation validation in terms of code reviews, penetration testing, security vulnerability assessments, and so on. In that sense, you do the assessment from an ingredient perspective for the building blocks, and also for the ecosystem. What happens when you piece these things together? So once you piece these things together, you often see that there are new kinds of challenges, because you're working not only with your own platforms, but also with third-party hardware, third-party software, with partner ecosystems, and so on. So many a times, use of free and open source software can be the weakest link when it comes to security. So making sure that you're taking care of all that kind of the security threats and the exposures, a combination of manual as well as tool-based security assessments. So that should be your plan from an SDLC perspective. Privacy is something that's indispensable when it comes to IoT and when it comes to healthcare. So it's no longer SDLC. Sometimes we refer to it as SPDLC. It's really security and privacy development lifecycle. And lastly, SDLC or executing these activities, it's not like your annual health check. You don't just do it once and forget about it for a year. This is something that is continuous as long as you push updates, as long as there is new code, especially when you're talking about cloud and using cloud-based systems for doing CI/CD, continuous integration, continuous deployment, continuous delivery. New vulnerabilities can crop up. All it takes is one architect or one DevOps engineer to make a change in the way your VPCs are configured, in the way your databases are accessed, and then that can leave a gaping hole, right? So continuous security becomes very imperative, because as I said, the attacker needs to get it right only once, but as defenders, you need to get it right every single time, right? So that brings me to the end of my presentation. I hope this was useful, and if there are any questions, I'm happy to take them now.
Thank you so much. That was indeed a very detailed presentation. So given that we have limited time, I would invite first the Innovation Center's startups. If you have any questions, please come forward one by one, and then we can open it up, given we have any more time left, to the others. So anyone who has questions, please unmute yourselves and go right ahead. Any questions? Please feel free to come forward. Okay, so we have one question. Samantha, I'll just take that up.
Sure.
Do we have any regulations around security and privacy of medical devices that has an ML component?
Right. So that's a good question. So this is something that has been is becoming a concern of late because of the use of AI and ML in the healthcare space. Remember one slide where I talked about the building blocks of a medical device or a healthcare IoT ecosystem. One was labeled as an SAMD, software as a medical device. So that's the closest, I would say, where if your product has an ML component and it's purely software, or you have these algorithms running on the cloud. I see another question on the same lines. Your product, your solution may be considered as a software as a medical device. I'll give you an example. If let's say you're using third-party hardware, which have nothing to do with what you provide as a service, but you're using that in a healthcare environment, let's say in a hospital, to collect certain information about the patients. So it could be gathering some kind of vitals or some kind of information related to patient health. You may be processing all that data and providing a report by acting on the data in the cloud using your own algorithms, which could be ML, which need not be ML or AI. But if you are providing some sort of a diagnosis based on that information, your product may be labeled as an SAMD, which means if, again, you are processing data in a particular geography, it could be the US, it could be Europe, you will be required to comply with the same kind of regulations that we talked about in terms of the FDA 510K, the MDR, IVDR, or in India under the IT Act. Hope that answers the question for both. I see a question from Therma Scan. I wonder if health data collected in India has to be stored in Indian data center cloud, or is it possible to store outside? So this is a pretty good question. Again, so data residency has been one of the topics that has been discussed under the PDP, where there has been a lot of discussion about whether sensitive data belonging to Indian citizens and individuals residing in India. I'm not a lawyer, so I don't want to be very specific there. But there has been a requirement that talks about ensuring or requiring such data to be physically present in India. So if yours is a company that is processing data and managing it, it would be prudent to start looking at some of these data residency requirements so that you don't have to deal with it at a later point once you're already in the field. One of the projects that we worked on at Deep Armor actually did this. Where this group was working on a telemedicine platform. And after consultations with the central as well as the state governments, we got a lot of kind of a requirement and guidance from these entities saying that all the data has to be resident in India. So the project was using AWS, so we made sure that the data centers that AWS was that they were using under AWS were all physically located in India. So short answer, it would be very prudent to consider that such requirements are going to come in the future, if not already there. There's a question about could you name the acts again? So in India, there are two draft laws. Again, just to emphasize the fact, these are not enforceable as of today. One is DISHA, DISHA, and the other one is called PDP, the Personal Data Protection Bill. So neither of these are enforceable. So the only enforceable act or the law is the IT Act of 2000, where there is protection for sensitive and personal information. In the US, it's called the US FDA 510K, 510K. It has a separate cybersecurity guidance. And in Europe, it is the CE mark, under which we have the MDR, the medical device regulation, and the in vitro device regulation, IVDR.
Thanks for answering those questions, Sumant. If we have any more questions, there's still some time. Yes, Sumant, if that would be okay with you, we could pass along the recording.
Yeah, absolutely. That should be fine.
Sure. Anybody else who has any queries? Okay, then. Well, thank you very much, Sumant, once again. It was a really interesting session, very insightful. Thank you also to Shija and the team at NASSCOM and everyone who's joined us today. So we'll free up a little bit of your time, get your cup of coffee or tea, and on to your next meetings. So till we meet again, stay safe. Thanks, everyone.
Thank you very much, everyone. Thanks a lot, Dolly and Shija. So it was a pleasure talking to all of you today.
Thanks.
Thank
Bye.
you. Bye. Bye.
Thank you.